Greetings everyone and welcome to reInvent 2020. Thank you for taking time to attend this session to hear about Symetra's journey as a Greenfield organization on the cloud to becoming a digital native business. My name is Sandeep Kashyap and I'm a Technical Business Development Manager at AWS. Joining me in today's session is Chuck Chemis, Principal Cloud Architect at Symetra, an AWS customer, and Matthew Carlyle, Senior Consultant with Second Watch, AWS Premier Consulting Partner. In today's session, we will be covering Symetra's journey as they started in the cloud on AWS and go deeper into how they build the foundation of their cloud environments. We will also look at how Symetra is enabling self-service migrations to enable their application teams to move their workloads into the AWS cloud. So let's start with Symetra's journey to using AWS. Symetra is a financial services company that offers insurance products such as annuities and life insurance to its customers. It's been in business for over 60 years and has over $55 billion in assets. Symetra operates primarily in the US and its parent company is Sumitomo in Japan. Symetra is a privately held company headquartered out of Bellevue, Washington. So when Symetra started to engage with AWS, which is almost over 2 years back, the main requirement was to migrate multiple workloads from on-premise to AWS. In the beginning, Symetra had about 100 engineers and developers and only 3 AWS experts. So given the lean cloud experience, that definitely was a challenge. Now, while Symetra did have an existing governance practice and a model for their IT operations, it was not something that could easily be applied to the cloud. And especially with a business that requires Symetra to adhere to financial and healthcare regulations, security and compliance were always the top asks right from the beginning. And finally, with a large portfolio of in-house as well as public-facing applications, the desire for the management right from the beginning was to build a self-service model for migrating from on-prem to the cloud. So let's see how Symetra has built their cloud enablement program. The first part was to build the team for which they hired a program manager, a cloud architect, and a policy manager to ensure that there is no unauthorized usage of the cloud. They wanted to make sure that in the beginning, they do limit the access to the cloud so that they could build a foundation which could enable them in a move slow to a move fast approach. The next thing the Symetra cloud team did was to prioritize the education across their organization and answer questions such as why the cloud. They continued to host sessions such as Coffee in the Cloud over a 3 to 6 month period. And the cloud team continued to drive awareness within the organization by way of newsletters and weekly meetups to help develop a community within the organization. The Symetra leadership also made a very concerted effort to train and certify their people on the cloud. And working with AWS, they developed learning paths for their engineers that started with immersion days, where engineers would build components that they would actually use in their day-to-day work. And Symetra put their skin in the game by providing incentives for people who would get certifications by giving them stipends and bonus cash awards. All of this was possible because their efforts were aligned with the digital operating principles, a set of principles that were built by the CIO office and aligned with the C-suite. This provided the required executive sponsorship. These principles helped Symetra to transform from a mainframe-centric company to a cloud-enabled digital native business. I'd like to focus on 2 principles today. First is cloud first for new content and applications. In this, because Symetra is all in on AWS, any new application they built using native AWS services before looking for any third-party solutions. The second principle was to adopt a DevOps model and drive through automation for all resources that were to be consumed. They put in rules and regulations such as nobody should provision any services from the console, and everything should flow through the infrastructure as code pipeline. One thing I'd like to call out, and that sets Symmetra apart from the rest, is to build cloud infrastructure before adding any workload. What Symmetra did was to build the foundation, the security, and the networking, and complete the training before any engineer would build any workloads or applications on the cloud. This has allowed Symmetra to move very quickly once they've started to move workloads, and hence comes in the approach of move slow to move fast. At this point, I'll hand it over to Chuck to take us in depth into how they've built their landing zone and their foundation on the cloud.
Thanks, Sandeep. When we started our cloud journey, we frequently heard, that's not how we've always done it. I came across this quote in the beginner's mind, and it helped me understand some of the organizational challenges we were facing. How do we get our teams new to the cloud to think in a new way? Sometimes it means they have to unlearn what they currently know or how they currently do things. Sometimes it's having a bit of blind trust, encourage them to take the time to immerse, experiment, learn about new capabilities, and then apply this new learning to what they know. Basically, what we challenge our teams to is, imagine if Symetra was a born-in-the-cloud company. What would it look like? When we started our cloud journey 2 years ago, we did all the basic things that folks would expect, right? We designed a multi-account structure around lines of business, our tagging strategy. We reserved our IP space, built our VPCs, defined our connectivity, and the like. What I'd like to talk about next is how we actually leverage Control Tower and the account vending machine to build our landing zone and implement various guardrails. In addition, I'd like to also describe how we procured software through the Marketplace, and also talk a little bit about our automation around building our golden AMI. So let's talk about the multi-account structure. So first off, we have an administrative control plane that our team uses to basically manage the cloud fabric itself. So at the heart of this is AWS organizations, which is where we apply our SCPs, Control Tower, which is where we apply our guardrails, as well as our account vending machine. Most of this we drive out of CloudFormation stack sets. And then likewise, we federate our identities through SAML, and then this is also where we apply all of our IAM policies. Okay, so let's talk about some of our foundational accounts. So we have a login account, which includes AWS Config, AWS CloudTrail, and this is where we centrally aggregate all of the logs from all of our various accounts. The next foundational account is our security management, and you can see that we have Security Hub, Shield, Guard Duty, Amazon Macy, and the like, but this is where we bring and administer all of our security products together. And then the other part is what we call our shared infrastructure. This is for our networking services. This is where we bring all of our connectivity into be. This is where we define our edge. We actually also leverage the transit gateway, and then basically we've built the hub and spoke model that then services all of the other accounts. And this allows us to keep all of our routing in one place and control that from this hub. For operating models, one of the things that we have is 3 different types of account structures. And these are, as you might imagine, the typical non-prod, integration, QA, or quality assurance, as well as production accounts. And we break those accounts kind of into 3 structures. We start off with what we call our traditional accounts. Those would be our in-tier types of applications. And what's common to this operating model is how they use agents, and they're typically EC2 based. We also have a SQL database and the like. The next type of category that we have for our operating model is our serverless accounts. And it is what you might imagine. It's API gateway, it's Lambda functions, and other types of serverless technologies that we bunch all together there, because how we support and manage and basically monitor those accounts are different between our traditional accounts versus a serverless world. And then the final account area is that what we call our protected accounts, which is where we have to meet certain compliance needs, such as HIPAA. So we have additional controls that take us outside of those other 2 types of account boundaries. The third area I'd like to talk about is what we call our walled gardens account. And so the walled garden accounts we implement through RAM, our Resource Access Manager, and excuse me, and through that, we really only need to change the administrative functions associated with that. We don't need to rebuild VPCs and define all this routing. So through RAM, we're actually allowed to associate our walled garden accounts with specific types of underpinning networks. So whether they're be protected or serverless or traditional, that's what we attach the walled garden accounts to. This allows us to do very specific types of special needs or isolation that's really defined more around the administrative boundaries versus the network infrastructure. Let's talk some more about some guardrails now. So we start off with our policies and roles. So within AWS orgs, we define all of our coarse-grained controls. And this is implemented through SCPs. And some examples of these SCPs would be, mostly they're written around deny rules, but basically we would want to deny the ability to disable AWS config or Cloud Terra or CloudWatch. We also would deny, for our protected accounts, your ability to add, say, non-certified services, like for HIPAA, for example. For identity management, we follow a least privilege model. This is where we implement our fine-grained controls at. And so we take these IAM roles and we define them around job functions. So we have admins, developers, databases, some people that really just need to look at the cloud, some of our services like through a read-only. And like in the developers, one of the things that we do is we actually define multiple levels. We have a full stack developer 01, an 02, and an 03. And basically, when a new person comes in that's new to building in the cloud, we'll put them into a developer 01 role with a common set of services. And as they grow their maturity, we'll elevate them up. Or if we hire in from outside and someone who's very experienced in building in AWS, we'll put them into the developer role 03. And the full stack 03 role basically allows them to have power user access. For preventative and detective controls, this goes back to how we deploy through Control Tower. So we have about, I think, 20 plus preventative and detective controls. And so like an example might be config rules that would detect if somebody tried to set a S3 bucket public, for example. Okay. We also have, and this is what we call our event-driven bots. And these event-driven bots are really Lambda functions. They detect, remediate, configure, and to our specific rules and standards. So an example is what we would say all S3 buckets have to be encrypted. We would also, through these Lambda functions, remove overly permissive security groups, such as allowing RDP from a non-compliant corporate address. We would also block any unrestricted inbound access from the internet. Now, pulling all this together, our structure and the way that we approach this was really to say we are a highly regulated company. So how do we implement all these various policies and guardrails and prove that we can actually maintain our compliance and regulatory requirements? So what we basically have done is we pull all of this together and we say our coarse-grained controls and SCPs are really where we apply at the organizational unit, and those are our preventative controls, and they are always compliant. At the fine-grained level, this is where we, again, as I talked about earlier, we apply IAM policies and the like. And then this is possible that we could get out of compliance there with some of that. But what we really want to do is bring all of this together and then run services behind the scene through things like Security Hub and AWS Config and say, where do we have non-compliant issues at, and then how do we then bring that all together and bring that back to our user so that we can get that not only corrected, but then how do we use these dashboards to actually show to our auditors how we're meeting these certifications. By aligning to these patterns, we've actually, this year, we're able to achieve our ISO 27000, as well as pass multiple security audits. We do see a future whereby we can leverage this style of compliance reporting and hopefully displace our needs as a company to have to bring in different auditors and third parties, where instead we can actually provide these reports to them. So prior to adopting Control Tower, it would take our team over 4 hours to execute multiple scripts, and it was a very manual process. It was highly complicated, error-prone, and anytime we had to add a new rule or update a change or a new policy, quite a bit of effort, and we didn't always get it right. With Control Tower, we're able to actually do this in less than 30 minutes. We can create a new account, and it's really easy to maintain a common baseline. Updates and changes can easily be applied with very little effort. I have a quote here for one of our solution architects. He and I actually happen to share the same name, father and son, probably one of the few father and son cloud builders that you'll find out there. But wanted to point that out, okay? So another thing that as we mentioned earlier on and Sandeep talked about, which is that we have digital operating principles that drive us down a pattern of cloud native, cloud first, cloud native. So cloud native says that when we have to deploy a set of services, we need to start with AWS first. Well, what do we do if AWS doesn't have a particular service that we need? Our second option is to go to the AWS Marketplace. This allows us to very rapidly provision new services. You can see some of the vendors that we've used in our ecosystem, and I can share that one of our stories was that we actually tried to bring some on-premise security technology forward. It didn't behave well in the cloud, so we flipped over to the marketplace, and we're actually able to pull down from Palo Alto, for example, some next-gen firewall capabilities, as well as we've been able to enhance some of that security reporting and compliance reporting by using the Palo Alto Prisma Cloud. So the next area that I want to talk about is a core building block for hardening our images. And we have a very limited engineering. We're a small staff. We're very lean. And so one of the things that we look to as a cloud team is to see how are our engineers actually performing their task. And while they may have pieces of automation that they write, is there a way that we could actually bring all that automation together? Think about a factory where we take a process in, run it through the factory, have the predictable, repeatable outcome on the backside of that. And through that process, we can actually remove some of the dependency on that engineer and free them up to do other tasks. So what I like to do is share about how we go about our golden AMI. So we basically have a listener that from an SNS topic that says there's a new AMI of the images that we support that's available. We take a look at that image. We have a Lambda function that kicks off and compares what we have in our parameter store. If it's not one that's there and we say this is a new image, through this automation, we kick off Systems Manager, execute a series of run commands as well as SSM documents. We launch an instance. We apply our hardening capabilities to that. We literally create an install of our agents, and then we create basically a new image that we then launch a new instance with, apply that, some additional automation, and then when we're done with that, we basically run it through AWS Inspector. It emails out a report. Likewise, we pump that same information up into the security hub and then evaluate those findings. And then our engineers then look at those results. If they approve them, we will then rotate the AMI that's in the parameter store and basically then publish that out to the service catalog so that through our service catalog, when we need to do a new build, whether it be a Windows EC2, a SQL, a Linux box, or we always have the most current AMIs out there for our new build process. At this point, I'd like to pass over to Matthew to describe more about how we've automated migrations using the service catalog.
Hi, thank you, Chuck. In this part of the presentation, we'll talk about migration and the multi-year migration that Symmetra has embarked upon. As we talked about earlier in the presentation, we are taking the time to do things right, prepare, do some tooling ahead of time so that we can move slow and then move fast. One of the main problems that we have in this type of environment is that the application development teams don't have a lot of experience in AWS. We're moving to AWS from an on-premises VMware type of environment, and we have a lot of people with Windows skills. So we have teams. We don't want to just throw people into the console and tell them to start building EC2 instances. So the solution that we've come up with is to enable the teams through self-service to manage their own environments, build their own servers using templates that we produce, with the cloud team acting as subject matter experts. The benefit of that is going to be that we will have fast velocity. We won't be in their way. Once the teams know how to use the tools, they can build their own servers, and as well, they'll start to get experience in the console itself and get AWS experience. We'll be using AWS Service Catalog for this, and if you've used that, you should be aware that it is a way of taking CloudFormation templates that you can bless and produce, and then sending them out to teams so that they can build their own infrastructure using those templates. So we have two main approaches at Symetra. We're doing re-platform and rehost. The majority of the products we have in front of us are re-platform, and that is our preferred approach. We would like teams to be able to reinstall applications on new servers using blessed AMIs, but of course that's not always possible. And so we also do a rehost using CloudEndure from on-premises and a block-by-block copy to bring those servers up to AWS. And so just look at a few of these products that we have here. We have network services, DNS entries, certificates, load balancers. We have compute, so teams can build EC2 instances. It could be Windows or Linux, all from golden AMIs, and using volumes and EBS volumes that of the appropriate size, provisioning, and so on. Importantly, we can enforce tagging standards doing this, so we know that these instances will appear with the right tags, which obviously is a struggle within many organizations and becomes important for cost showback and chargeback later on. Database-wise, we support EC2 and RDS. EC2 for Microsoft SQL, and RDS we do MS SQL, we do MySQL and Postgres as well. And importantly, the database team help produce the templates, so they are blessed. Every database appears in the same way. It's configured in a way that they can support, and they don't have to set it up. From a file storage perspective, we are using FSX for Windows and moving people over from the standard on-premises Windows shares to FSX. An important aspect of that is cost containment. We don't want to allow people to use some of the very high bandwidth and expensive file shares. It's really not too much of a need for that in general, so we're able to limit the options using Service Catalog and template constraints. For rehost, we're offering a server migration product, and that's what we'll talk a little more about in the next slide. There's already some automation in this area at Symetra, and his name is Greg. He put together a lot of the processes. He goes onto servers, RDPs, he installs CloudEndure agents, shuts machines down, and does a lot of the work. So Greg's great, but there's only one Greg. We can't scale Greg, and he might want to go on vacation. And as good as Greg is, he can make mistakes. So we decided to automate Greg with Greg's help, and to turn Greg into a product. So what we have here is the way that this works is a migration project manager, and ultimately this would be the application teams themselves, but initially it's the migration team. They go into Service Catalog and create a migration product. And if you know how Service Catalog works, as we talked about, it'll instantiate a CloudFormation stack under the hood. And this stack is rather empty. It's kind of a fake stack. It contains a bunch of outputs. And then we use that to kind of drive the migration. And when you do this, you create this stack, this Service Catalog product, in the destination account where you want your server to be migrated to. When that's created, we're using a notification constraint in Service Catalog to send messages via the topic and then ultimately to a Lambda function. And that Lambda function is just watching. When it sees a stack has been created, it knows that a migration is needing to happen, and it jumps into action. It creates an entry in a DynamoDB table and creates an AWS step function execution. AWS step functions are great for things like this because it's good for long-running processes, things you wouldn't or couldn't do in a Lambda invocation, for example. That step function is using a Lambda handler for pretty much all of its job. It's this one Lambda function that does and handles all of the step function transitions. The first thing it's doing here is it's going to send you an email that says, congratulations, we are starting a migration for this particular server from the data center into AWS. It shows you your tag, shows you what's going to happen, kind of keeps you informed, and you get emails throughout the process as well. The first thing we have to do is to get the server replicating from the on-premises data center to the new environment. We use Systems Manager for that and SSM docs. So we run an SSM doc that goes out to CyberArk to retrieve credentials and then reaches out to the server and installs via a PowerShell script the CloudEndure agents. And the CloudEndure agents when provisioned with the right key, will then reach out to CloudEndure and also start replicating to the destination VPC. So we have infrastructure already set up for that and waiting. Replication can take a while. It obviously depends on the amount of bandwidth you have, depends on how big the servers are. In our case, it can take typically a few hours or so. We have dedicated bandwidth for this. It's a process that's constantly being monitored. You don't have to do anything. What's happening is the Lambda function and the step function is just checking in every 5 minutes via the CloudEndure APIs to see how things are going. Once it's all done, you will get an email. And the email simply says, congratulations, your server is ready to go. Click here if you would like to launch your server. So when you click the link, you're actually clicking a link and doing a get on a particular link, and that's an API gateway link. So that link releases the step function to move towards the next phase, which is to launch the server. And it's a little more complicated than some of the previous phases because we have to uninstall some agents from the server. So we uninstall some particular AV agents. We want to use different ones in the cloud, and we uninstall some management agents that don't make sense in AWS anymore. And then we have to wait for the uninstallation to synchronize through CloudEndure. So we do the uninstall via SSM docs. Then we ping CloudEndure and we wait for the kind of replication to catch up. Then we run another document to shut down the server because we don't want to launch two servers that are Windows domain joined servers and on the same name. That would confuse things. Everything's on the same network. And then finally, we hit the CloudEndure API to launch the server. And it's when the magic happens within CloudEndure, and then that server appears. We're watching for that server, and eventually you will get an email that just says, congratulations, this is your instance ID, your server information, IP address, and so on. And then you can RDP to that server or do whatever you need to do to it. In production, we have some work to do because as we enable self-service, we want to make sure that people can't just migrate random servers that they don't own, for example. So we need to integrate with ServiceNow for change requests, linking change requests to CIs within ServiceNow, and so on. So somewhat of a lofty goal, but we believe that with additional integration, we'll be able to do this. And now I will hand back to Chuck, who's going to talk more about what's next at Symetra. Thank you.
Thanks, Matthew. So for the next steps in our self-service automation journey, on the technical side, what we're looking at is deeper integration with our internal platforms, such as ServiceNow, our ITSM platform, and we're looking at using the AWS Service Management connector for that. We also are looking at doing some enhancements to our Service Catalog, including adding App Composer and App Registry. And on the operational side, additional bots to help us detect, remediate, maintain our tagging compliance, and actually applying as a team more focus on managing our costs using AWS budgets, right-sizing resources, and purchasing of saving plans. In terms of organizational change management, we want to continue to break down our IT silos by empowering our dev teams to take ownership and sharing the responsibility of our security as well as managing the runtime costs. And then finally, what I like to say is for those starting their cloud journey, I'd like to leave you with this message: think cloud first and let go of the past. Thank you for your participation today. And next, I'd like to hand this back over to Sandeep for some closing comments.
Thanks, Chuck. Hopefully the session has been of interest to you. We can recommend a couple of takeaways from this session. You can use the practices that Symmetra followed to develop a community of experts across the organization who are aligned on the core principles. And you can work on the management and governance best practices and principles and define and expand them as per your organization's requirements. Once you're ready, build your landing zone with AWS Control Tower and use the solutions on AWS Marketplace to become operationally ready and further optimize your operational practices. You can use AWS Service Catalog to build self-service into your AWS environments. And for those organizations which use ITSM solutions such as ServiceNow and Jira Service Desk, you can use the AWS Service Management connector to enable end users and engineers to consume AWS services. Thank you so much for joining today. To learn more, visit the AWS Marketplace software procurement information page and check out the other AWS Marketplace and AWS Data Exchange sessions scheduled over the next few days. And do remember to submit or complete the session survey. Thank you, and have a great rest of your reInvent.